Amedio Avogadro versus Gay-Lussac. Now, this is our class 3 on gas law. Here we'll talk about the law of combining volume of gases. Before you can understand this thing, the first class we did, we talked about Boyce-Charles and idle gas. The second class talked about the Dalton's law of partial pressure. Now, these four scientists, or three scientists rather, lay emphasis on the physical properties of gas, whereas the Gay-Lussac law and the Avogadro's principle talks about the chemical properties. We are going to begin with the Gay-Lussac law, but before that, please share this video and always support me when you see my video. To like my video, you can also comment and then you share. Thank you. Now, Gay-Lussac law stated that for gas to react, they do so in volume. Are you getting me? Which bear a simple whole number ratio to one another and to the volume of the gaseous product, provided that they are measured in the same condition of temperature and pressure. You get this? I repeat again. Gay-Lussac law states that for gas to react, they must do so in volume, which bear a simple whole number ratio to one another and to the volume of the gaseous product, provided that those gases are measured in the same condition of temperature and pressure. Now look at this statement. I want to say, for example, if hydrogen gas react with oxygen gas, I'm going to have what? I'm going to have H2O. Notice that this is a gas and this is a gas. This here produced is a what? A liquid, aqueous. Are you getting? Now, what is needed here? If I should balance this, I have 2 to be here because 2 must balance oxygen, that is 2 here. And since I now have 2 times 2, 4, I will make here to be 2, so that 2 times 2 will be 4. Balance equation. Now, according to Gay-Lussac law, it says that for these two gas to react, they do so in volume, which bear a simple whole number ratio to one another and to the what? Gaseous product, provided that these two gases was measured in the same condition of temperature and pressure. That means temperature and pressure must be what? Constant. So what does it mean? It means that here, as you can see, this is the whole number ratio. An invisible one is here, which is also the whole number ratio of oxygen that is needed to react with hydrogen to give us what? 2 molecules of water. So this man here say that before you can get water, this is a stem, water stem. Before you can get this, you must use 2 volume, all right? 2 volume of what? H2 and combine with what? 1 volume. That is the what? Whole number ratio. Combine with 1 volume of what? Oxygen. To give you what? To give you, or let me just put it, to give 2 volume, 2 volume of what? H2O. So this will guide you on your experiment as a science student, so that if you want to do any reaction, remember that the Gay-Lussac law said that you will need a what? 2 hydrogen to react with what? 1 hydrogen, 1 volume of hydrogen to give you what? 2 HCl. I will make 2 examples. Now we will talk about the Avogadro's principle. The second example is, let's use ammonia, for example, or let's use HCl. Which one should we use? Let me know what you think on the comment section. So I'm choosing HCl. No, I've used H. Let me use ammonia. So we have that N2 plus H2. These are gases. This will give us ammonia according to A.R.A process. Now, balancing the equation, I have what? 2 nitrogen here. So this must be what? 2. All right. I have what? 2 times 3, which is 6 hydrogen at this side. I must have what? I must put what? 3 here to have 2 times what? 3 to also give me what? 6. Now, according to this Gay-Lussac law, we have noticed that whenever that we want to do experiments and produce H ammonia, we need what? We need a whole number ratio of volume of nitrogen, which is what? 1 volume of what? Nitrogen to react with what? 3 volume of what? H2 in order to have what? 2 volume of ammonia. All right. Now, this is according to what? Gay-Lussac law. Now, there is a problem on this Gay-Lussac law. What is this problem? This Gay-Lussac law is so much important, but because he did not relate Dalton's theory on his gaseous reaction, we have some drawback on his law because we cannot use kinetic energy of gas to be able to explain his theory. You get that? But however, when Gay-Lussac died, a scientist, may he rest in peace, another scientist known as Avogadro now have a link connection from Gay-Lussac law to Dalton's law theory, where he stated that the volume, that's I'm stating the word Avogadro's principle, where he stated that the volume of all gases under the same condition of temperature and pressure contains equal number of molecules. So we talk about volume, the volume of all gases under the same condition of what? Temperature and pressure. They must be constant. Are you getting? And if they are constant, they bear the same number of what? Molecule. Directly proportional to what? Number of molecule. Hence, we can say that volume is what? Molecule. Are you getting? To have volume, you must have what? Molecule, which is number of what? Molecule. And increase the number of molecule, we increase the volume of the what? Gas. What did I mean by molecule? For example, if this is a cup and you're using it to measure rice, the rice you have here, 11111, is what we call what? Molecule. That will be what? Molecule of rice. Now, when you measure the rice with 1 cup, we call it what? 1 mole of rice. Because rice cannot be counted, we are going to be measuring it with what? Moles. That is why some classes we are not going to talk about molecule, we talk about what? Mole. That is just the meaning of what? Molecules. All right. So that is the number of molecules of any gas. We increase the what? Volume. So if this rice should keep what? Increasing, if you keep adding rice to this cup, so that it will be what? Above the what? Cup level. That is what the volume has what? Increased. But we're talking about what? Gas here, just for you to what? Understand. Now, because of this statement of fact that 2 volume of what? Hydrogen react with what? 2 volume of oxygen to give us what? 2 volume of hydrogen, I cannot summon it up to be what? Under Gay-Lussac law. Gay-Lussac law. And I'm going to make another statement because volume is proportional to what? The number of molecule. I'm going to say that what? 2 molecule of what? 2 molecule of H2 is needed to react with what? 1 molecule of what? O2 to give us what? 2 molecule of what? H2O. And this one will summon up to be what? Under Avogadro's principle. You get that? So when you're using molecule, you're relating to what? Avogadro's. When you're using volume, you're relating to what? Gay-Lussac law. Now, this Avogadro's principle now relates to what? Dalton's theory. Because from a molecule, we are going to know that temperature is going to be affected and the kinetic energy may decrease or increase depending on what? Temperature. And the pressure will also what? be in what? Unstable. So this here was what? Accepted, but we still use what? Gay-Lussac law somehow. According to also this reaction, we can say that this one is summoned up to what? Gay-Lussac, and here avocados will now become one molecule react with what? Three molecule to give us what? To give us what? Two molecules of what? Non-H3. All right. Now let's look at chemical calculation. Chemical calculation on this Avogadro's principle or Gay-Lussac law is based on direct proportion. For example, you might be given a volume of this gas and you're not given a volume of this gas and you're given a volume of the product to be able to find a particular volume of what? Hydrogen. You're going to relate it back to the chemical reaction you may be given. Just let's look at example. In this first question, please listen very well. We have that water vapor is produced according to the following equation. You have this, and to give you this. Remember how to pronounce it. Now, according to what? Gay-Lussac law, we say 2 volume of hydrogen plus 1 volume of oxygen to give us what? 2 volume of what? Vapor. Or according to Avogadro, we say 2 molecules of this plus 1 molecules of this will give us what? 2 molecules of what? This is still what? The same thing. Now, this is how water, what do they call it? Water vapor is produced in this what? Reaction. Now, what volume of oxygen will combine with 10.0 cm3 of what? Hydrogen. We are looking for a volume of oxygen that will combine with 10 cm3 of what? Hydrogen. And how many cm3 of water vapor will be produced under the same condition of temperature and pressure? As simple as, let's repeat this to have this gas plus O2 gas and give us 2HO, also a gas. Now we have that 2 volume. I want to use what? Volume, because we are having what? Volume combined with 0.4 cm3 is a volume. So I want to use what? Volume. 2 volume of this is going to react with what? 1 volume of this to give us what? 2 volume of what? H2O. What does this mean? It means that for you to get water vapor, you must use 2 volume of what? Hydrogen, and react with what? 1 volume of what? Oxygen to get what? Water vapor. However, the question says that what volume of oxygen is needed to react with 10 volume of hydrogen? Now you have what? Volume of hydrogen, but you don't have what? Volume of what? Oxygen. Remember I said that we do this with what? Direct proportion. So I'm going to say that what? From this place, from this expression, I'm going to say that, okay, now since 2 volume of hydrogen is very much equal to 1 volume of what? Of oxygen. All right, so this is very much equal to this because they can react. Hence, if I have the volume of hydrogen to be what? 10 cm3, 10.0 is just like 10. So if the volume of hydrogen is what? 10 hydrogen, will also be very much equal to what? S oxygen, which I do not what? Know. This is S is what? I don't know. I'm looking for the what? That volume of oxygen that will react with what? Or that react with hydrogen, because I want to do it under what? Direct proportion. Just like if you have 60 seconds make 1 minute. If you're not looking for maybe X seconds, that will give you what? 2 minutes. What are you going to do? You cross and multiply. 2 times this will give us what? 120. Okay, I'm correct. Now S times this will give us equals what? S1. Hence S, which is what? The seconds is what? 120 what? Seconds. Now from here, to get my S number of volume of oxygen, I'm going to cross multiply, direct proportion. S multiplied by 2, which is what? The volume of hydrogen, will give us what? 2S. Then multiplied by 1 volume of oxygen needed to react with 2 will give us what? Equals what? 10. Now I'm looking for s, not 2s. I'll divide by 2, divide by 2. This cancel this. S is equals what? 10 over 2 is equals what? 5. Hence, 5 what? Volume of what? Oxygen will react with what? 10 volume of what? Hydrogen. I getting? So the question say what volume of oxygen will react combine with 10 cm cube of what? Hydrogen. So now we can say that 5 cm cube of oxygen will combine with what? 10 cm cube of hydrogen. Remember how I got it by saying that since 2 volume of hydrogen can react with 1 volume and they are very much equals to, hence x hence 10 cm cube of what? Hydrogen, it will be equals to what? Unknown value of what? Oxygen. You cross multiply. Now that is what? The first what? Question. The second question says of hydrogen. It says, and how many cm cube of hydrogen vapor will be produced under the same condition of what? Temperature and pressure. All right, this is very what? Simple. I said we always do this using a what? Direct proportion. Now, according to the direct proportion, I have that 2 hydrogen is very much equals to what? 2 what? Water vapor. Because if you look very well and closely, you're going to find out that from this place, 2 volume of what? Hydrogen is very much equals to what? 2 volume of what? H2O. Are you getting? Hence, if this is equals to, we want to get what? And how many cm3 of what? Water vapor was produced. Now, we have that the reaction was with what? 10 cm cube of what? Hydrogen. We are going to say that what? 10 cm cube of what? Hydrogen, or we just put it what? 10 hydrogen, that is volume of what? Hydrogen. That is under this same reaction, because this reaction was given to us as an example of what? The condition needed to form what? Water vapor. Now the second reaction we do, we not have what? 2, but we have what? 10 hydrogen. So if 2 hydrogen is very much equal to what? 2 water vapor. Hence 10 hydrogen will be very much equal to what? Unknown water vapor. All right. Hence, if I cross multiply, s multiplied by this will give us what? 2s equals to 10 multiplied by 20 will give us what? 10 multiplied by 2 will give us what? 20. Divide by 2, divide by 2, s is equals to what? 20 divided by 2 is what? 10 cm cube. So that 10 hydrogen will react with what? 10 hydrogen. All right. Sorry. 10 hydrogen will produce what? 10 water vapor. I mean to say, sorry. Now, you can also use what? You can also use with oxygen. Since from here, one volume of what? One volume of oxygen is very much can produce what? 2 volume of what? H2O. All right, because we are looking for the what? Number of what? Water vapor that was produced on this second reaction. We now say that what? We now say that okay, since the second reaction have what? 5 volume of oxygen. Now 5 volume of what? Oxygen will now be very much equals to unknown volume of what? H2O. Now to work furthermore, we what? Cross multiply.